Bismillahirrahmanirrahim. We are going to start question number 8 of exercise 2.2. It says that we have to consider any two particular matrices A and B of our own choice of order 2 cross 3 and 3 cross 2. What does 2 cross 3 means? That there should be 2 rows and 3 columns. These are 2 rows and 3 columns, and I've named it A. And the second matrix, which is B, has the order 3 cross 2. 3 cross 2 means 3 rows and 2 columns respectively, and show that AB means the product of matrix A and B whole transpose, that when you find their product and a matrix is deduced from it, we have to take its transpose, and this should be equal to the transpose of B. So first of all, we are going to take its transpose and then its transpose, and then we are going to multiply them both in the order given, and then they both should be equal. So for first of all, we are going to start right hand side, which says AB whole transpose. AB whole transpose. So we are going to write AB over here. So I've just copied this A matrix and B matrix over here in the form of AB, and then whole transpose is written as it is. Now we have to multiply these two matrices. So what is the rule for multiplication? That the number of columns of the first matrix, which are 3, should be equal to the number of rows of second matrix, which are also 3 over here. So we can multiply them both. They are eligible for multiplication. Now we are going to multiply them. We should also keep in mind that the resulting matrix, the result of the product of these two matrices, would have the number of rows equal to the first number of rows of the first matrix, and the number of columns equal to the number of columns of second matrix. So this should be in your mind. Okay, now we are going to start multiplication. For the first entry of the matrix, it is the first row and the first column. So the first row of the first matrix and the first column of the second matrix, you are going to multiply them both in a way like this. Okay, 1 into 2, 102 will be multiplied with 204, plus 0 into 0 gives us 0, and 2 into 4 gives us, we are going to write it over here. Now this is the second row and the first column of the resulting matrix. Second row and first column. So second row and first column. Now we are going to multiply them. 0 into 2 gives us 0, plus 3 into 0 gives us again 0, and 4 into 4 plus 4 into 4. Now we are going to, okay, keep it in mind that I've just written them of my own choice. You can do it with your own choice. They are just up to you, whatever you want. Okay, now the third entry is in the second column and first row and second column. So we are going to take the first row and second column. So multiplying them, we get 1 into 3 plus 0 into 1 gives us 0, plus 2 into 0 gives us again a 0, and then this entry would be in the second row and the second column of the resulting matrix. So second row and second column, 0 into 3 plus 3 into 1 and plus 4 into 0. So 0 into 3 gives us 0, plus 3 into 1 gives us, just we are going to write it right now, and then 4 into 0 again gives us 0. Now we are going to write it in matrix form. Now we have drawn these brackets over here, square rectangle brackets, and then we have to also draw this T sign over here to show the transpose, that we have to take transpose in the end. Now our matrix would be in this way. 1 into 2 gives us 2, plus 2 fours are 8, 8 plus 2 gives us 10. Then 1 into 3 plus 0 are produce no change. Okay, so 3 over here, then 4 into 4 gives us 16, and these zeros cause us nothing, and then 3 into 1 gives us 3, and then hold a transpose. And now we have to write it in by taking transpose. So we are going to change the rows into columns and or columns into rows, whatever you like. Okay, the result would be both of them. So I'm just going to change the rows into columns. The rows are 10, 3 and 16, 3. 10, 3 is the first row, will be changed into the first column. So we are going to write it as 10 and 3. And then this is the second row, will be changed into the second column. So 16 and 3. Now this is your answer for the left hand side. Now we have to solve the right hand side to check if both of them are equal or not. Okay, the right hand side says B transpose A transpose. So we are going to write it here, B transpose A transpose. For this we need B transpose and A transpose matrix. We are only having B and A, so we have to take the transpose to solve the right hand side. So first of all, we are going to take A transpose, which is equal to, now we are going to change this first row into the first column. So the first row is 102 which will be changed into the column form 102, and then the second row is 034 which will be changed into the second column, so 0 3 and 4. Now we are going to find B transpose, which is equal to, just wait for a while, okay, B transpose will be equal to, by changing the rows into columns, so the first row is 2 3, 2 3 will be changed into the column, then the second row is 0 1, 0 1 is the second column, and the third row is 4 0 over here, and we'll change it into the third column 4 0. Now we are going to write them both over here and multiply them, so it is equal to, for multiplication, many students do this mistake that they first write A transpose and then they write B transpose. This is not the right way of doing it. You'll get your answer wrong. So for this, you have to write in the same order as in the given question. It is B transpose, A transpose. So first of all, you are going to write B transpose and then you have to write A transpose. You can't change this order because this will give you different results, okay? Now we are going to multiply these two matrices together. For the condition that makes two matrices eligible for multiplication is that the number of columns of the first matrix should be equal to the number of rows of the second matrix. So there are 3 columns of the first matrix and 3 rows of the second matrix, so they are eligible for multiplication. And the second thing is that how many rows and columns which will get how many rows and columns will we get in our result. So we are going to get the number of rows equal to the number of rows of first matrix, which are 2, and the number of columns equal to the number of columns of the second matrix, which are also 2. So we are going to get a 2 by 2 matrix, okay? So for the first entry, we are having the first row and the first column. So first row multiplied with the first column, we get 2 into 1 plus 0 into 0 gives us 0 plus 4 into 2. Then this is the second entry, which is in the second row and first column. So second row and first column, so we are going to multiply them. 3 into 1 plus 1 into 0 gives us 0 plus 0 into 2 also gives us 0. Then for this entry, this is the second first row and second column. So the first row and second column, 2 into 0 gives us 0 plus 0 into 3 gives us 0 and plus 4 into 4. Then this is the last entry, in which we are having the second row and second column. So the second row is to be multiplied with the second column. 3 into 0 gives us 0 plus 1 into 3 gives us 3 plus 0 into 4 gives us 0. So now we are going to solve all these entries and calculate our result. So the first entry would be 2. 2 ones are 2 plus 4 twos are 8. So 2 plus 8 gives us 10. Then 3 and plus 0 0 change nothing over here, 3. Then 4 into 4 gives us 16, and then 3 plus 0 gives us also 3. And now we can see that the left hand side equals our right hand side. So not red, it is right hand side. So left hand side equals right hand side here, and we have proved it. Thank you so much.